In Lesson 6.4, we're solving compound inequalities. You'll learn to solve compound inequalities containing the word and graph their solution sets, and to solve compound inequalities involving the word or and graph their solution set. You're all dying to know, how are compound inequalities used in tax tables? Richard Kelly is completing his income tax return. Woot woot. He uses the table to determine the amount he owes in federal income tax. Let C represent the amount of Mr. Kelly's income. His income is at least $41,350, and it is less than $41,400. This can be written as C is greater than or equal to $41,350, and C is less than $41,400. When considered together, these two inequalities form a compound inequality. This compound inequality can be written without using and in two ways. Either C is greater than or equal to 41,000 and less than 41,400, or not as commonly, 41,440 is greater than C, which is greater than 41,350. A compound inequality containing and is true only if both inequalities are true. Thus, the graph of a compound inequality containing and is the intersection of the graphs of the two inequalities. In other words, the solution must be a solution of both inequalities. Graph the solution set of y is greater than or equal to 5 and y is less than 12. They have both graphed y is greater than or equal to 5, so close circle on the 5, arrow goes to the right, and y is less than 12, open circle on the 12, arrow goes to the left. So the summary, the final graph, would be that third one. So that's y is greater than or equal to 5 and less than 12. And they want us to graph z is greater than 7 and less than or equal to 11. All I need to do here is subtract the 2 from each piece of the inequality. And I'm going to have 5 and z and a 9. So z has to be greater than 9 and less than or equal to 9. So it's connect the dots scenario there. The book shows this by graphing z is greater than 5 and z is less than or equal to 9, both graphs, and then combining them. In my mind, I think it's okay just to start with the simple graph that they end with. I think my solution of just open circle on the 5, z is bigger than that, so I'm going to the right until I get to closed circle on the 9, means the same thing as what they did. A ski resort has several types of hotel rooms and several types of cabins. The hotel rooms cost at most $89 per night, and the cabins cost at least $109 per night. Write and graph a compound inequality that describes the amount that a guest would pay per night at the resort. They decided to let C represent the cost of staying at the resort per night. So the cost per night is at most $89 for a hotel room, or at least $109 for a cabin. So our two inequalities are going opposite directions. This is an or scenario. So either C is less than 89 or C is greater than or equal to 109. So we would sum this up. C is less than 80 or equal to 89, or C is greater than or equal to 109. And our inequalities going opposite directions, so the arrows on our number line are also going opposite directions. When we solve inequalities with an or in between here, using a union, we're just going to solve each one by themselves. So to undo minus 7, I'm going to add 7 to both sides of the inequality. So 4k is less than or equal to 32. And undo times 4 divided by 4. So k is less than or equal to 8. And then start over here. So subtract 12 from both sides of the inequality. So negative 9k is greater than or equal to 18, and divide both sides by negative 9. Oh, I divided by a negative, so I need to reverse that to k is less than or equal to negative 2. Now that is kind of unusual because both our inequalities ended up pointing the same way this time. Okay, so for an or, usually we plan on them counting and going out, But think about what or means. So pick a number. I like 0. Okay, is 0 less than 8? Yes. Is 0 less than -2? No. But this is an or, so it only has to be true for one of them. So our final answer is going to be, oops, I used k instead of x. K is less than or equal to 8. A compound inequality containing or is true if one or more of the inequalities is true. The graph of a compound inequality containing or is the union of the graphs of the two inequalities. So union means we're putting them together. In other words, the solution of the compound inequality is the solution of either inequality, not necessarily both. In summary, the solution of a compound inequality containing and is the intersection of the graphs of the two inequalities. The solution of a compound inequality containing or is the union of the graphs of the two inequalities.